Okay, hello dear students. This is the second problem on radial line development. A square pyramid of side of base 45 mm, altitude 70 mm is resting with its base on HP with two sides of the base parallel to VP. The pyramid is cut by a section plane which is perpendicular to VP and inclined at 40 degrees to HP. The cutting plane bisects the axis of the pyramid. Obtain the development of the lateral surface of the truncated pyramid. So to start with, it is said that there is a square pyramid of sides 45 mm, altitude 70 mm, and it is resting on its base on HP with two sides of the base parallel to VP. So this is how it should be rested. It is resting on its edge position. Why? Because it is said that the pyramid is resting on HP with two of its edges, that is 1 and 2, parallel to VP, parallel to the XY line. So I've considered B1 C1 and A1 D1 edges 1 and 2. These two edges are parallel to XY line. So this is how you position it. Once you do this, you're then going to label all the points A1, B1, C1, D1, O1 and do all the dimensioning of this. Then project all the points so as to get the front view of this square pyramid. In order to get the front view, initially you start with the axis line. So the altitude, that is the height of it, is given as 70 mm. So from this O1 dash to O, you draw it as 70 mm. Once you get the apex of this pyramid, then you project down all the points, you connect all the projected points to the apex. So you have all the markings and all the ends that are joined here. So this is the front view of the pyramid that is drawn with a pencil that you see here. The pencil that you marking or the drawing that you see, that is the pyramid in its front view. Once you complete that, then you have to go for the development of this pyramid. Once you have to go for the development, then as per the principles of development, the development has to be in its true dimensions. In order to get the development in its true dimension, you have to have one of the edges to be parallel with respect to XY line. So here, when it comes to one of the edges being parallel to XY line, if you observe here, the edge OC1, edge OD1, OA1 and OB1, all of these are not parallel to XY line. So what we have to do is, we have to virtually move one of this edge parallel to XY line and then get a slant edge drawn such that it will represent the true dimensions of the slant edge. So what we can do first is, you will have to draw an auxiliary HP, or you can say just a line which should be parallel to XY line. This is just for construction purpose, but it has to be parallel to XY line. You draw a edge. You can draw this edge either on this side, you can take it on this side, you wish, whichever side you wish to. I've considered this side. So first I have drawn one line which should be parallel to XY line, and then with the help of a compass, by keeping the center of the compass here, I have measured the distance till D1 and then drawn an arc such that it should cut this line which is parallel to XY line. Okay, from this, at this point, this is the new D1. I have labeled it as D11. Now this point has to be projected straight on top to get the slant edge in its true dimension. So can you observe, this is the new edge that we have constructed so that we can get one of the slant edge in its true dimension. The same can be done even on this side by considering one line that you draw parallel to XY line. You can move the edge A, or you can also move the edge OC1 down in this direction. So the direction will be now downward direction. If you're taking this, it will be in the downward direction, but I have considered OD1 and therefore I have got the new slant edge in its true dimension, that is OD1. Okay, I have not marked D11 here, it should be D11. So this is the slant edge in its true length, that is the blue color line that you see, and this has to be used in order to go for development. So this is measuring 77 mm. So with the help of a compass, by keeping the center here, you measure 77 mm, and by taking this apex here, you can mark 77 mm and take an arc with that 77 mm as the radius. Once you do that, then you measure what is the base edge. It is 45 mm. With the help of a compass, you mark all the points on this arc, A, B, C, D and A, erase off all the extra arcs that are there, and then you have to join AB1 A1 B1 B1 C1 C1 D1 D1 A1, because it is the base edge and not the arcs. We are opening up the pyramid. When you open up the pyramid, it has the base edges. So here the arc that you use is only for construction purpose. Once you do that, then you have to go for actual marking of 1 2 3 4 in order to get the development. In order to get the development, as I said, you have to have all the true dimensions. Let us see which of these markings are on the true dimension. But before that, let us see how the sectioning has to be done. It is said that the pyramid is cut by a section plane which is perpendicular to VP and inclined at 40 degrees to HP. The cutting plane bisects the axis of the pyramid. When it is said bisects, it has to be at the midpoint of the axis. So initially you measure 35 mm and draw an auxiliary HP here at 35 mm, and then to this it is inclined at an angle of 60 degrees. So you keep your protractor here and mark an angle of 60 degrees with respect to HP. So this is your auxiliary HP that we have drawn, which is bisecting the axis, and then with respect to this HP you are going to measure 60 degrees, that is shown here. So this has to be extended such that it cuts all the edges of the pyramid. Once it cuts all the edges, then we'll go for labeling the marking of 1 2 3 4. 1 on OA1, 2 on OB1, 3 on OC1, and 4 on OD1. So let's see, where is OA1? On OA1 it is intersecting here, so this will be 1 dash, and as OA1 is visible, it is nearer to the observer, it is not put in bracket, whereas OB1 and OA1 are overlapping. So the point of intersection for OB1 is also at the same point where there is a point of intersection for OA1, but as it is behind, as it is not nearer to the observer, I have put that in a bracket. Next, let us mark 3 dash. 3 dash should be on OC1. You see this plane, it is intersecting here, so this is 3 dash. As it is away from the observer, I have put it in the bracket. And then you have 4 should be on OD1, which is again intersecting with the point of OC1, that is 3 dash. So you have 4 dash also marked here. Once you get 1 2 3 4 marked, the same have to be marked here. If you observe, as these edges OB1, OA1, OC1, OD1, they are not in their true dimensions, they are all apparent dimensions that you see, but the marking here should be done with respect to the true dimension. So all of these points are projected on the true dimension slant edge, and then with respect to O you measure that distance and you mark it here. So first of all, 1 dash, 2 dash, this point of intersection I've pulled up here, I've projected up here on the slant edge which is in its true dimension. From O, with the help of a compass, you measure 1 dash and mark it on OA1. You can mark it here as well as here. Next, O2, 2 dash, it should be on OB1. Then 3 to 4 also, because it is not in its true dimension, you have to project that on the true dimension slant edge. Measure O2, 3 dash, you mark it on OC1. You measure O2, 4 dash, it should be marked on OD1. Once you mark 1 2 3 4 and 1, you connect all of these points with edges because it is a pyramid. Then the edges which are also part of this development should be darkened. So this is how the development has to be done. So this is a condition where the edge, any one of the edge, you should always try to identify which edge is parallel to XY line, and that edge should be